we will take another simple example, prove that square root 5 is irrational. Same arguments. We'll start off with an assumption. So what is the assumption here? Square root 5 is a rational number. So if square root 5 is a rational number, so if it's a rational number, which means it must be in the form p by q. So we will write square root 5 as some a by b, where a and b are co-primes. So when I say a and b are co-primes, which means there do not exist any other number which divides a and b, which means a by b is already in the simplified form. Okay. Okay, so let's start this one. So if this is our assumption, we will come to a point where a known thing will not be a true. Therefore, our assumption must be wrong. So we will come to that point. Let's see this one. So let's simplify. So square root 5 whole square. So square both the sides. So let's call it as 1. So square 1 on both the sides. So then we get 5 is equal to a square by b square. So this implies we'll get this b square this side. So it becomes a square is equal to 5 times b square. So now here we are saying a square is equal to 5 times b square, means a square is some multiple of 5. So if it is some multiple of 5, which means 5 must divide a square. So if 5 must divide a square, then 5 also divides a. By the theorem that we have studied, if p divides a square, then p also divides a. So if 5 divides a square, 5 also divides a. Okay, I'll call this one as equation 2. Now what does this mean? If 5 divides a, then it means that a is some multiple of 5. So since a is some multiple of 5, then I'll take let a be some 5 times k. Okay, so if a is some 5 times k, so let's substitute this one. So let's call this one as 3. So substitute 3 in 2. Okay, so a I'll put it as 5k. So this becomes now 5k whole square is equal to 5 times b square. So this is 25k square is equal to 5b square. So 5 ones are 5 to 5s are. So b square is now 5 times k square. So again what we are saying, so b square is again some multiple of 5. So if b square is some multiple of 5, so 5 divides b square. So if 5 divides b square, then this implies 5 also divides b by the theorem that we have studied earlier. So what did we end up here? So we started with an argument saying there are no number which divides both a and b, but finally now we are saying 5 divides a as well as 5 divides b, which means 5 divides both a and b. So if 5 divides both a and b, our this argument becomes wrong. So that is definitely not possible. So therefore what must be wrong? Our assumption must be wrong. So square root 5 is a rational number is a wrong assumption. So what should be true? Square root 5 must be an irrational number. So let's write that one. Since 5 divides both a and b, which is not possible by this argument, correct? Because we are assuming a and b are co-primes, both a and b, which is not possible. Our assumption must be wrong. So if our assumption must be wrong, square root 5 is irrational. That is the argument that you make. I hope you understood this one. So next, what we'll do, we will generalize this one. So what do you understand from this? Square root 2 is an irrational number, square root 5 is an irrational number, and so on. So which means square root of any non-perfect square will be an irrational number. Okay, so square root of any non-perfect square is an irrational number. So that is the takeaway from this one. So we are going to use this fact later in order to prove a little complicated problem.